Fabulous. Cool. All right. Welcome everyone to our release highlights session for Weaviate 1.29. My name is JP. I'm an educator in the Weaviate Developer Experience and Education team. We've got Alvin with us, who is our VP of Product, which is very exciting. So thank you for coming. And we've got Sebastian, who is our Director of Developer Experience and Education. So thank you all for joining. The idea is to go through some of the big highlights for 1.29. Sebastian is going to tell us about part of that as well. And then Alvin, who's graciously very glad to have with us, will tell us a little bit about some of the even more exciting things coming in the future in our pipeline. Thanks, Alvin. The enthusiasm is palpable. So this is like a rough agenda. So the top few are basically features, the key sort of really exciting features that we have in 1.29. So I'll just go through them one by one. I've put time slots mostly as a reminder to myself. So let's see how we go. Cool. Let's start with multi-vector embeddings, which is really cool. And I'll start by with a little bit of background. For those of us who's joining, a vector embedding kind of works like this. You might be familiar with it, but the idea is that you have some sort of an input, whether it's text or whatever, and you end up with a vector. What does that vector look like, or where does it come from, excuse me? And it comes from a machine learning model, like a neural network, as you see here. And in that process, what you'll see is that there's a first process, which is tokenization, where the input gets broken up into smaller pieces. And each of these tokens eventually or essentially get turned into a separate vector, and the neural network does its magic thing, which is where you would have heard the term transformer ad nauseum, and it gets turned into a vector at the end of the day. And the vector looks like a series of numbers. So that's what you're used to. It's also called you can also call it a single vector embedding, and they tend to have quite a few dimensions, like 128 to 1500 or so. Now, with those types of vectors, when we perform distance calculations, this is what we do, right? So you start with a vector for the query, you start with and then you have a vector for the corresponding document embedding that you're comparing against, and you'll compare them by whatever the distance metric is, typical cosine, but could be dot, Euclidean distances, what have you. And that's the distance metric you'll see if you perform vector search in Weaviate or in other third-party libraries or what have you. So that's a 2-minute rant about single vector embeddings. So what's different about multi-vector embeddings? What's changed and why are we talking about it? The key difference is that when you have, or let's start with similarities. When you have a multi-vector embedding, you still have a neural network that converts one to the other. And you still have tokenization that happens. The key difference is that with a multi-vector embedding, you get these in multiple individual vectors as one embedding. So that means that instead of having one sequence or one list or array of numbers, you actually get a multi-dimensional array or list of numbers up to something like 8,000 vectors. Now, in the individual vector in it tends to be smaller in that instance. And as you saw just earlier, a single vector distance calculation looks a little bit like this, where you're comparing one vector against another. But actually, when you have a vector distance calculation for multi-vector embeddings like colBERT, what you're comparing is a set or a series of vectors against another series of vectors. So the calculation gets quite complex in that sense, because what happens is you start to compare each embedding, so each vector within the embedding against all of the other vectors in the document embedding, right? And you get a distance, or what typically is called a maxim metric out of that. And you do this for all of the query vectors. And you sum them all up, and you get an eventual resulting distance. The good news is, at the user level, like at the application level like us, you don't actually need to know all of this, but it is useful to know what the intuition behind this is, right? So what might be different about these types of embeddings versus the flat or 1D embeddings?
Can you explain what max sim is? I might have
Yeah,
missed that. Sorry, JP.
Okay. Yeah, no, thank good question. The maxim in this case is what happens is this first vector you see here on the left-hand side, when it gets compared to each of the constituent vectors on the right-hand side, you'll have a series of similarities, right? And the maxim is basically a method where you're just saying, okay, let's take the maximum similarity value out of the series of similarity comparisons, right? So basically it's saying, okay, this token vector matches this other token vector the best, and that's got the highest score out of all the other comparisons. So we'll keep that one. So it's basically a way to identify, as the intuition for that would be that it's a way to identify what part of the input text matches what part of the input text best matches what part of the document text, right? And the maximum value gives you the degree of similarity. And that gets to kind of like the intuition that I was trying to get behind, which is that with the 1D embeddings, all of the kind of vectors for each, so all of the token vectors or the constituent vectors get flattened out. So you end up getting like this overall averaged out meaning of an input. Whereas with colBERT or multi-vector embeddings, it preserves those individual parts of a sentence or a meaning, if you will, so it can perform these comparisons later. And again, you don't need to know the details of it, but someone in a similar session we had internally was asking about a use case or application, why you might want to use this type of model. And I think one answer is, well, because it preserves those individual tokens' meanings for longer, we'll be able to, um, it'll be able to more, it'll be able to pick up the individual kind of composition of a sentence or token matches of particular words and whatnot. So that's kind of a short background on um, colBERT or multi-vector embeddings, and this is what the code usage for that might look like. I'm just going to minimize that. So what I've done is to set up some Jupyter, like set up a Jupyter notebook, where I'm getting embeddings manually to start. So I'll just, what I'm doing is using the Jita API to get embeddings for both the traditional or the 1D embeddings here. I'll just make that a little bit larger. And also using colBERT endpoint to get colBERT embedding. So don't worry about the code, but that's what I'm doing here. So now if I have the same input text as shown here, and I get embeddings using both methods, I can see that they have different shapes of arrays. And again, this is 1,000 dimensions of a single vector. And this has 7 vectors, each of 128 dimensions. Interestingly, with colBERT, what you'll see is that if I have a different piece of text as an input, so here's some slightly longer input, what you'll see is that the output is longer. So this is a 2D matrix. It's kind of like a taller shape, if you will. And it happens because you're representing more tokens as the input sentence is longer. You'll see that a lot of this text here that I'm using is, there's a fair bit of it. I'm specifying the model and embedding type. I'm making a request call into the API, blah, blah, blah. The good news, obviously, as usual with Weaviate, is you don't need to know a lot of that to use colBERT with Jina, because we have this handy model integration organized. So all you need to do is to pass your Jina API key here, or whatever integration, but in this case, I'm using Jina. And these 5 lines of code is really all you need to specify to be able to use the colBERT model. So what I'm doing is I'm specifying that this collection will use the Jina colBERT model to vectorize my data from the text property. And that's it. So I've got a couple of properties here defined for text and doc ID, and I've created a collection just like that. And I've got some input text, some fairly arbitrary input text here and I'm going to insert that into Weaviate just in a second. And here's my just, 4 or 5 lines of code to insert that into my database. And once I run that, um, it'll just take a couple of seconds. I found that this particular API can take a little bit to start up, which is kind of interesting. So some of the latency here is not from the Weaviate side. So the API is just being periodically, sometimes a little bit slow. But once I've done that, I can run searches to say, oh, let's find the best matching object for a good database for AI-driven products. And you can see that actually this output is the first match has a lot of entries where at the token level, there's an exact match. So that's another thing you'll see, as I mentioned with colBERT, where if you have exact matching tokens in your input or the query versus your document, they tend to score quite highly. And if I want to run different types of queries like near text, I can do that. Oops, query without even converting my input into a vector manually. So in this case, again, you'll notice that I'm not converting any of the input data into vectors manually because Weaviate abstracted all the way for me. And there you go. That was quite quick. And I can do the same thing with hybrid searches and so on. So yeah, that's in terms of being able to use this integration with Weaviate, it's super simple. As always, the only difference is that you're specifying the Gina colBERT integration, and we'll have more colBERT or colPaly, excitingly, for images, I think, coming in the near future, which is very, very cool. Um, Going back to the slides. I've got just one more slide on this, which is the multi-vector embeddings resources. So if you're looking to get started with multi-vector embeddings, we've got this tutorial, and that's a kind of end-to-end workflow that you can check out from start to finish. I will mention as this particular page notes that this feature is in technical preview, so it may change in the future. It's not generally available just yet, but it's very, very cool. So I'm very excited to use it. And I actually have been using it in quite a few demos myself. The other thing I'll say is that there's also our handy model integrations guide. So you can have a look at that to see how we specifically integrated the Gina colBERT model. Of course, I'll just mention this since I've got time that I've assigned to myself for a couple of minutes. If you don't want to use the particular Gina colBERT model and, for example, want to use a colPaly model for which you can create the vectors yourself, you can do that by specifying the vectorizer as none. And again, this is very similar to what you might have done with the custom or the user provided vector workflow, right? The only difference is that when you create your vector index here, you need to specify that this is a multi-vector embedding. So it's like a one-line change from the previous syntax with non-multi-vector or the 1D vector. Cool. Hey, Scott, you got a question?
Yeah. When we choose multi-vector, does it create a vector per token, or is that
Okay.
maybe more with the embedding
Yeah,
model? How does that work?
with the I guess the embedding creation is done outside of Weaviate. But it tends to be you kind of get something like a vector per token, but there are limits as to how many input, like there are limits to the shapes of those things, both in the input side and the document side. So um, there's kind of limitations there, and I think there's different, I guess, tricks that these models use to get around that. Yeah, it's a really good question. And there's like lots of cool things we do at Weaviate from the index creation level as well. Hey, Jimmy, did you have a question?
Sorry, yeah. The same embedding needs to be produced for the whole document series. Like, for instance, if I have one body of knowledge And let's say I'm using a hybrid search in one case where I've got traditional embeddings and I'm running a traditional similarity search and maybe with a BM25. And if I wanted to add a colBERT type late interaction search like what we're doing now, I would have to take my existing body of knowledge and re-embed that in this method.
Yeah, that's exactly right. So at the moment, I think you do need to re-vectorize it. I believe in the future, we're looking at adding the ability to introduce additional vector spaces to your existing collections. But I believe for now, you'll have to re-import the data. Okay, so that's about it for the multi-vector embeddings. I think, Sebastian, should I hand over to you for this?
So what I want to talk to you all about is role-based access control, or RBAC. And then, so the idea behind it is that in your database, you have various resources, right? Like, of which probably the most valuable one will be your data collections, right? So maybe in my case, I have like some docs pages, docs authors, blogs, secret stats, but also you have like other types of maybe services that maybe you want to run backups and you want to be able to manage that. There's all sort of node informations around your clusters, etc. You could access this information. So far, what we've done, that you would have access to everything, right? Like if you can access Weaviate, you can access it, you can access all of this, and you can do pretty much anything to it. But obviously, this is not how you want to work with databases quite often, and you have many, many different users. Some of them could be people, some of them could be even machines and services. So what we introduced with RBAC is that we can look at those resources and say like, okay, so maybe we can have some built-in roles, right? This is already what exists at the moment. So you have some built-in roles, but we also have them as part of our RBAC. So you could have an admin and a viewer, right? So in a way, I should have played with the animations a bit better. But the built-in roles, like an admin, will have like all sort of like read, write, like pretty much everything towards everything. If you have an admin role, that role can do everything. If you have a viewer, the viewer, on the other hand, it's mostly around the read-only sort of permission. So a viewer will have access to all the collections. You'll be able to read it, but not necessarily make any modifications. And in the past, we've actually worked where if you had to share your API key, maybe somewhere as part of your, I don't know, JavaScript application, etc., that's usually where the viewer would come in, because in the worst case, somebody could just query your data that you're exposing. But the next stage is kind of like, okay, what if I was able to create my own custom roles, right? So in this case, maybe within my organization, I could have a docs team or the blogs team, or maybe a special service team. So in this case, the docs team, for example, could do all sort of reading and writing on the docs pages and docs authors. Maybe the blog reader role could just read the blogs collection, but nothing else. While the service team, maybe we would want it to just be set up to backup and to run backups and restore the data. So you can kind of actually go around and then create those roles with your own custom permissions. And then once you have the roles, you can start assigning them to your users. So in this case, for example, I could have a user that is Sebovita, that's me. Let's make me an admin. Why not? Then Ivan on my team, who's basically running the docs, for example, could be assigned to the docs team. Then you have JP. JP could be both, be a blog reader, but also work on the docs team. And then finally, maybe you can have Mike in the SRE team. That's kind of like part of the service team role, right? So through this, we can then kind of actually say like, okay, so me as a Bovita, I can do all of it. Ivan could probably create new stuff or read both the docs collections, while JP can work on the docs authors and pages, but also can do some of the blog reading, right? And Mike can run backups and restores. That's sort of the idea. And that's kind of like the key concept behind it. So like we mostly look at like, hey, you have a resource, you then create roles that have permission to these resources, And then eventually you take users and then assign them roles. And that's kind of like how you can move on with this. So I want to jump into the code to show you how all of this runs in action. Yeah, that should be good. So what I have in here is I want to just show you how all of this works from Docker Compose, right? So far we've already had these environment variables. So I could set up like the authentication API keys. So there's a user, there's a key. So maybe in here I can add, say, JP and say, okay, JP's secret pass 1, 2, 3, right? Like I can create a JP like that. And then while you are working on RBAC, we need to enable it. So this is the environment variable, and we can specify who are from this list, who are the users that should be the root users, right? Roots are basically like admins. So they have permissions to pretty much do everything. But the key information from here is that this user Sebawita with this password or API key is capable of creating other roles, because you at least need to have at least one admin to do all of this. So if I run my Docker container, I should be able to do that quickly, and now I should have these users. So if I go into the code, I can do the following, right? Like, so when I connect to Weaviate as part of the auth credentials, I can pass in my API key, and I can get an info about it. And you can see that like Weaviate already knows that I'm Sebawita, and I have like a whole bunch of permissions, which is basically the root role. And then with that, I can start creating various permissions, create new roles, etc. So let's imagine we have those two collections. One's called docs authors, another docs pages, and I want to create permissions for them. So what you can do is something like this. I could say, okay, I want to have permissions, and then you can see there's already different types of permissions that I can play with, right? So, okay, let's say I want to create a collections permissions, and usually you would start with the resource. So I can say, okay, I want to do something for the docs authors. And then in this case, I want to say, okay, I want to be allowed, this role should be allowed to create collections and maybe delete collections, right? And then just doing this, I can set this permission. Separately, we can set permissions maybe for the data. So we've actually separated what you can do to collections from the data collections. So I could actually follow a similar pattern, say, okay, for the docs authors, I want to be able to create. So it's the same like thing as insert. Maybe let's allow also to read. So set it to true. Read is like also equivalent to query, and then also allow to delete some data. And then by doing this, I can basically set up this set of permissions. Something else that I can do, I could actually set up these permissions one by one for every collection, or I could use patterns. So if I do this wildcard and say docs star, anything that starts with docs will then also apply to it. So if I actually intend to have multiple collections that start with docs and I want this role to have these permissions to that, I can use this pattern, which is very, very useful. And then final thing that I really need to do is just use the client roles create. So it's very similar to the patterns that we've used in the past with managing collections. But I can say, okay, the role name, let's call it docs team. And then the permissions should be these docs permissions. So this is an array. I can pass it in. I could have written all of them here, but that's besides the point. But just running this is how I just created a docs team permission, right? I could very quickly check if the role exists, like super straightforward, docs team, boom, yeah, it's true, right? Like if I say 2, it doesn't exist. So it's quite cool. I could also list all the roles. So that's pretty straightforward. So you can see we have our docs team here together with all the permissions that are over there. But there's also 3 built-in roles. So there is like an admin role, root role, and a viewer role. So the root role is mostly assigned through the environment variables, while the admin and viewer could actually be assigned dynamically to users. So I could actually go and say, hey, I want to make JP a viewer or an admin, but I can't do it with the root. Yeah. And then what you can do as well, if you say like, hey, maybe this role shouldn't be allowed to delete data, right? So what I can actually say is like, I want to update the roles, and then roles, remove permissions. So in this case, I can say role name docs team, and then permission. So this time I'm just going to type it here. And then so on the collection, what did I say? Docs star, I want to get rid of delete. Right, so if I run this after this, the docs team won't be able to delete any data from these collections. And then I can do the reverse, which is almost identical, where I can add permissions. So I say like, actually, no, I do want to allow them to delete and maybe even include update, right? So we can kind of update and remove the roles. But that's kind of like the key idea. So with this, we have now the docs team, right? So, okay, so we said that we had a user over here called JP, right? So what I want to do is just assign our docs team to JP, right? So if I say under client users, because this is a user permission, I might want to do the following. So the user ID is JP, and the role names that I want to assign. So it could be just a single string, or it could be an array. So it's up to us. But just for the kicks, I'm going to assign JP docs team permission, and also the built-in viewer role. And then by doing that, from now on, like if JP logs in with this JP secret pass, you'll be able to do all the permissions that are assigned from the docs, plus all the read-only permissions. And that kind of like works like magic. I could very quickly say, okay, so users, what is it like get assigned role? So I could check JP, and then I can see like, yeah, he's got the docs team and the viewer assigned. And maybe I overdid it, and I may want to actually remove or revoke role from JP. So in this case, user ID, JP, and then role. Actually, JP, you're not a viewer, sorry. You can only work with the permissions that you should be given. Yeah, and I think there's like a bunch of other things we can do. So you could say roles and say get assigned user IDs. So I could actually see who has access to the docs team. So you could very quickly kind of like get a list, etc. I'm not going to dive into like reviewing specific roles, but the key thing is now that, let's say I created this permission, so we could say, hey, JP can go and then create new collections starting with docs. So if I go and in here, I have a second notebook where we can pretend that we are a JP. So I can go in here, connect as JP, very good. And then first thing I want to do is create docs pages. So this should throw an error, right? Because there's a G, not a C. And you can see like we're getting like this super worrying error, but it's like, hey, insufficient permission error, forbidden. And then it says like RBAC authorization, forbidden action, user JP has insufficient permissions to create collection docs pages, because this should be DOCS, right? Which is super nice. So if we correct the mistake, I can go in and then create docs pages. I can go in as well and then create docs authors, etc., etc. We can, see. Oh, they should actually list the collections we have access to. Maybe I just need to update the database. But
Is it because I don't have viewer permissions, Sebastian?
oh yeah, you don't have a viewer permission. That's probably it. Yeah. And then finally, yeah, you have permissions to delete collection. Okay, so we should be able to create and delete this collection super quickly. That works fine. But if I come back, we're playing with revoking permissions, removing permissions. So what if I say permission collections and then change the delete collection to true? So I'm going to remove this permission from you. So you're allowed to create, but you shouldn't be able to delete collections, right? So look how fast this applies. This is available immediately. If I try to now create and delete collection as JP, we get an error, right? Like the first one works, the second one throws an exception. And then again, we'll say like, hey, forbidden action, insufficient permissions to delete this collection, right? And that's kind of like the key idea, right? Like you should be able to go, we have this docs pages collection, and then potentially say, hey, well, we're trying to add something in the docs pages, but because the docs pages, when we created it, where was it? Docs pages here. We didn't provide any schema. That also is going to throw an error. So this is more of a warning to you all that if you try to insert data, the auto schema tries to kick in, which needs permissions to update the configuration, which is a pretty good way to protect you from maybe changes to the data schema that you didn't quite expect. If I try to do an insert to the docs authors, where I did have already a schema provided, then you can see I can insert the data quite safely. So sometimes the permissions can also protect you from people making mistakes and then trying to, modify, update the collection configuration. And then I think the final thing, just to show, JP had the permissions to query the collection, so we can actually go create one of those. But if you wanted to make an update, you didn't have the permissions for that. So it's all up to you entirely how you actually run this. But it's actually pretty straightforward API. It's very, very powerful. So some resources that are worth checking. So these are the 3 documentation pages. To be honest, they're all kind of right next to each other. So if you have this link, you have the other ones. The first one is a bit of an overview. The second one talks about how you configure it, in Docker or Kubernetes, etc. While the RBAC APIs, or that's what I want to call, is how you actually use it inside the, different clients. What's coming up next is, at the moment, the users, you have to create them as part of environment variables. So we are actually just working on dynamic user management. So you should be able to create new users with API keys. Through API calls, we're also looking at managing all the users through OIDC and also introducing service users. So maybe you could have specific, special type of users that are only for running backups, but you don't want them to be kind of mixed up with the other users. That's it. That's me. I don't know if anyone had any questions or if I'm allowed to take questions.
Of course, you're allowed to take questions. Does anyone have any questions on that? By the way, if you have any questions after the fact, please do check out our forum, which I think is, what is it? Forum.weaviate.io.
Yep.
So, and we've got amazing people like Duda there. So please do check that out. I'll go back to sharing my screen. Also, I'm not sure if everyone's seen our website, but just on here, I just realized we've got these links, but I haven't actually shown any. But these links will take you to the site and to what Sebastian was referring to. All these RBAC pages are next to each other under the how to configure section. So thanks very much, Sebastian.
Welcome. I hope we have loads of people using RBAC. So yeah.
Yeah, and we've got, like you said, cool things coming on that front as well. I'll talk very briefly about Acync Replication. So the big change is that it's gone into GA. And if you're not used to replication, I'm sure many of you are, it's the idea that these information in each shard that are ultimately in some sort of computing device or nodes can be replicated in multiple instances, right? So that the idea then is that if one node goes down, it's being maintained, you have these other replicas that is serving user requests and has the data available if it's not recoverable, and so on and so forth. All of this means that there's this problem of how to achieve all this, how to achieve consistency within these models. And we've had what we call read repairs available, where as data is being read, if there's any inconsistencies between nodes and replicas, it'll fix that. But this isn't always perfect because you might not always hit the right replicas and so on. So that's why we've introduced these background async repairs. I won't go into the algorithm, but it's really, really cool. Basically solves the problem that direct comparisons are very, very costly. So we're using this algo called Merkle trees or hash trees. But the thing that makes it work is that each of these leaves cover changes to some part of your cluster. And again, as a user, all you need to know is that there is some sort of mechanism that will repair any inconsistencies that's developed in a multi-node cluster over time. So if you're interested in the computer science side of it, you can read about Merkle trees and so on, and that's really cool. But the idea that the only key thing that you need to know as a user is that this thing, A, exists, and it will look after maintaining consistency in your cluster. So these are some of the documentation aspects that you'll see. So in the concept section, we have the async replication, where it talks about exactly how it's implemented and why it exists and how it works. But from a more practical level, what we have is this how to configure async replication settings. So there are actually quite a few of these tunable parameters which will let you customize async replication exactly the way you need it. And as Sebastian showed in his example, these parameters are set up in your environment variables or in your Helm charts, and if you're running Kubernetes. But there are all these parameters available, so you can tune these to suit them. Of course, they are set up with what we think are pretty sensible defaults, so you don't have to worry about them so much in most instances. So that's async replication in 2 minutes. I'll talk about the NVIDIA model integrations fairly quickly as well. The NVIDIA model integrations is another one of the many model integrations that we have with Weaviate. Again, very similar to the examples you saw with Gina, to use Weaviate with NVIDIA hosted models. And for background, NVIDIA NVIDIA is now also an inference service serving a bunch of embedding models, generative AI models, and re-ranker models. But to use that, it basically is going to involve the same workflow as what you've been using with other model providers like your Coheres and Anthropics and whatever of the world, right? So all you need to do is pass your NVIDIA key when you connect to Weaviate. So you can see it's part of the header there. And then when you create a collection, in the text-to-vec, for example, all these integrations that we have, NVIDIA here is now a new option. So if you do that, now you've configured your model to be vectorized with an NVIDIA model. You can see I'm using one of the NVIDIA embedding models here, but they have all sorts of other models. And to the point there, for the generative AI use case, I'm using one of the Llama models here to do retrieval augmented generation, or RAG. And the rest of the workflow here would be exactly the same as if you're using any other model, whether it was colBERT or whether it was, a Cohere model or what have you. So we have a page here that so we have a page here. I'll get a complete sentence out eventually in the model provide integrations section for NVIDIA. And you can see we've got integrations for text embeddings, multimodal embeddings, generative AI, and re-ranker as well. And this will take you through to how to set that up, from connecting to Weaviate and performing queries and so on, whatever you need. Cool. I'll talk very quickly about BlockMax WAND because I know I don't want to run out of time for Alvin because that'd be really bad. But BlockMax WAND is this amazing improvement to, you'll see this really, really cool improvement to BM25 and hybrid searches. I assume a lot of you are using, yeah, thanks, Michael. Michael's very excited. For a lot of you using BM25 and or hybrid searches for your workflow with Weaviate. And it is an algorithm that improves the efficiency through which BM25 searches are done. And that means that in turn, your hybrid searches will speed up correspondingly. Now, in some use cases with BM25, as we say here in this blog post, this amazing blog post with Andre, we've achieved like 10 times faster, or I think one of the figures was 94% faster, something like that, depending on how you measure it. Much, much faster keyword search. So if you're if you're interested in the tech side of how this works, do check that out. The cool news is that to actually use it, you only have to set these, set these parameters to true in terms of setting the environment variables. So these environment variables are listed in our documentation page, and it's these two environment variables. I will note that at this point, it is a technical preview feature. So if you're interested in it, I'd 100% encourage you to check it out and share your experience with us. One limitation at the moment is that it is a tech preview, and you cannot migrate existing data by just flicking on these environment variables, and that won't automatically migrate your data. If you create a new collection with these variables on, then move your data into that new collection, that will do it. But at the moment, it's in a preview phase, and we haven't set that up just yet. But yeah, it's really cool. I learned a lot reading this blog post from Andre. He even has this very cool demo on the blog site about how BlockMax WAND works in comparison to traditional WAND. I'd love to go through it and probably, show you some of this off, but it's really cool. I, definitely encourage you to check this out. Okay, so that's all from me as well. And I'd love to, Alvin, if you're ready, I'd love to hand over to you and get the folks excited about some of the exciting upcoming stuff. So I'll stop sharing that.
I would love to. Right, let me do my normal. Can I get Zoom to behave with me?
Cool.
Right, hopefully you'll see a slideshow.
Yes.
Woohoo, exciting.
It's already a success, right? So many of you have not met me before. My name is Alvin Richards. I lead product here at Weaviate, and always looking to see what the community is after, what you're up to, what you're looking for us to do next. So please keep that feedback on the forums, on the community Slack, and all the events. All of that information is super useful for helping us figure out what we do next. Let me talk about what's happening next. So JP, Sebastian, awesome job about talking about the great things that are happening in 129. There are many things that are happening afterwards. So in the next 10 minutes, I'll try and go through this quickly. So we kind of think of the world in sort of three horizons, right? Today is that core Weaviate vector database and the native AI search, the hybrid search, and all of that goodness. And that's a continual investment that we'll continue to make. The sort of the next set of things that we're investing in is what are the things that we're building next that people think we'll need? So for example, the embedding service has just gone GA, and that's one of the additional things that we're adding to help our existing users be more successful using the product. And the kind of third horizon here is what's this new thing just over the edge of the horizon? And this is kind of how we apply agentic type workflows into Weaviate. And the first of which we announced it was today, I think. Was it yesterday? It was today, is the query agent. And so this month you'll hear a lot more about the agents that we're building. And it's very exciting, but just so that you kind of know from the bottom, it's just like we focus on that core vector database and those core features that help developers gain those insights out of their data faster. And then we layer on top of that core database these other features and facilities that we think help you in that journey and accelerate that journey, but you get to pick and choose which parts of this stack that you want to use. So if I kind of bucket those horizons, so what are we working on this year? So I call this Weaviate 2.0, but this is really kind of what are all of those sort of features that we want to put in to create this sort of the next generation of the core Weaviate database. How we think about operationalization of our cloud service, how we think about God, I can't speak now, JP. You've infected me. Right scalability. And so the kind of the next horizon, which is for our existing customers, what do we do about our cloud console? What about day two operations, right? You've got vector embeddings. How do you bring on a new model or a different quantization or add new vectors to existing collections? And the third horizon is all about, you know, our agents. I'll pick through some of these. So, you know, essentially, you know, a lot of the things we're doing is, you know, been on a theme to do billion scale of everything, right? I call to the engineering team, we should really call this trillion scale now because billion seems a bit old-fashioned. But you know, we've been doing billion scale vector search. You can see some of the stuff with BlockMax WAND. We're getting out to the billion scale of hybrid search. So we're continuing to add in those things that help the scale and allow you to do more with a greater set of data. We're doing things like the embedding service. There's new generation of clients coming out. We're currently focusing on the Java client and rebuilding it so it's more like the Python client, which would be epic. And you know, for those people in the .NET C# land, that's going to be next up on deck. So there's a lot of things in order to actually solidify everything in that product to get it to the next scale. The operationalized stuff. Well, this is a sort of, you know, a little bit internally focused, but ultimately the benefit is anybody using Weaviate. How do we deal with things like, you know, horizontal scalability, the resharding and the rebalancing, the vertical scalability across all the CSPs, you know, data reliability, availability, and recovery. So ultimately, the focus here is to make the day-to-day operation work with Weaviate be more and more automated, and that requires less emotional bandwidth to deal with, right? So we want to take away all the sort of, you know, the paper cuts and all the frictions so that you can spend time developing rather than spending time love caring and feeding for your Weaviate cluster. So there's a lot of great stuff that we're doing. And you'll see those projects coming to fruition throughout the year. So there's some great work that we're doing there. Right scalability. So it's great that you've got data that you want to vectorize. How do you do that at scale? How do you do that with a choice between it being super, super fast and kind of expensive because it's all in DRAM versus you've got data that may be not that highest order or the top tier of data, but you've got a second order of data that you still want to do the semantic search on because semantic search is really cool. It allows you to discover all these relationships in data that you didn't know about. But you want to do it in a more cost-effective way, and you're willing to trade off price for performance. So there's work that we're doing on sort of on-disk vector search to kind of allow you to give you that sort of that control. Because I imagine there's a big lever at the top of the screen that says, would you like this fast or would you like this cheap? And we want to give that sort of control back to the developer so that you can use different sets of data to apply on the semantic search. There's things working on that we've been working on for separation of read and write scaling, offline vector index creation. Ooh, 4 minutes to go. Cloud UX, anybody who's used our cloud console, it's kind of confusing who its audience is. So we're doing a whole bunch of reworks so that we separate out what the developer needs from what the admin or the operator needs from the person who cares about costs. There's also sort of a life cycle, which is what you need in a POC is very different from development and production. But I think one of the key things that we're focusing on is simply going from an explore experience of here's my cluster, here's my collections, here's the configuration, to start getting insights. So for example, showing you what it would be the impact in your recall if you were to switch the quantitization or switch the model, right? So throughout this year and next year, you'll see a swap from going from simply exploring what's there to try and gather you more insights that you can act upon. Day two operations. Now, this is my favorite part. You know, for developers, this is probably the least exciting thing, but your friend who has to keep the love, caring, and feeding of your data alive forever is going to care about this. So the basic motivation is you've chosen your model and your dimensions, you've vectorized everything is awesome. And then 6 months later, a new model comes out. Maybe it's a specialized model for your domain. How do you now take advantage of that model? And so this is where we're working on collection aliases, being able to alter a collection to add and drop new vectors, change model, alter quantitization, a whole bunch of stuff. Being able to build those indexes in the background, and then when they're ready, give you the ability to swap them out. And then doing things like benchmarking, so you can see based on samples of data, an A/B comparison of what those things look like before you do the mass conversion and revectorizing your gigabytes of data that you have. So day two operations is a big focus. It's the least exciting thing, but we believe it's a core focus to allow the vector data to continue to be useful over a long period of time. All right, 3 minutes left. Agents, I could spend hours talking about this, but there's lots of blogs you can read on our website. First up is the query agent. The easiest way to think of it, if you've used text to SQL, you can write a prompt in English and send it to the query agent. It looks at your collections in your schema, goes and figures out based on the prompt which queries to execute. They could be filtered searches, they could be aggregations, they could be semantic search. It goes and runs the number of queries it requires in order to answer the prompt, merges all those results, re-ranks them, and sends them back to you. It's super, super cool. Next up is Transform Agent, which is how do I take data and, for example, take my top 10 reviews and synthesize a new product description. So this is a way to take your existing data and use a prompt to transform or change that data. And there's going to be personalization and so on and so forth. And that leaves about 2 minutes left. JP, back over to you.
Thanks very much, Alvin. That's very exciting, and also I love the theme of providing TLC for your data, and I guess have it bear fruit one day, right? That's pretty cool kind of visual analogy there.
Yeah, there's a sort of analogy in Britain, which was an old Christmas advert, but your vectors are for life, not just for Christmas.
That's very cool. Yeah, thank you everyone for coming, and we'll hopefully see you next time. We have these sessions on every week where you can pop in and ask any questions you might have. So I really appreciate your attendance and your time. So thanks everyone, and thanks to Sebastian and Alvin especially.